Okay, Algebra 2 students, here's a video for example 3 for section 4.3. We're going to multiply rational expressions. What is the product of 2xy over z and 3x squared over 4yz? Multiplying rational expressions is the same or a similar method to when we're multiplying two numerical fractions. We need to look at the denominator and make sure certain variables can't equal 0, z cannot equal 0, and y cannot equal 0, so we need to keep that in mind. And then we write it all out. The numerators would get multiplied times each other, and the denominators would get multiplied times each other. Now you could, rather than just combine all those, let's see, how did they do that? Did they combine them all? And that is the method they use. Sometimes I cancel things out, but they multiplied them together first. Maybe not. 2 times 3, and then x times x squared is x cubed, and then there's still a y up top. And in the denominator, there's 4. They wrote it as 2 times 2, because they reduced it later. We have a y, and we have two z's. And then they cancel things out. The 2 times 3 divided by 4, they were both divisible by 2, so they canceled out the 2's. So we end up with 3 over 2 as the coefficients. X cubed, there wasn't any x's in the denominator. For the y's, there was a y in the numerator and in the denominator, so they canceled out. For the z's, there was only z's in the denominator, but nothing in the numerator, so it stayed as 3x cubed divided by 2z squared. Now keep in mind, that would be the answer, but we also need to have the restriction that y cannot equal 0, even though it doesn't show up in the answer, because up in the original, it was in the denominator. So y cannot equal 0, and z cannot equal 0. There's our final answer. Let's see, we're going to practice again. Yes, this time, oh, look at all that. That is huge. Let's see if I set that up for myself. Maybe, maybe not. I did not. That's okay, we'll just watch how they do it. It's times, so we're multiplying and multiplying. So we're going to multiply everything in the numerator together, but let's factor it first. So they factored all those numerators into 5x, x plus 3 times x minus 2, and then an x times x plus 1. And in the denominator they had an x plus 3, and this factored into x plus 1 squared, and then this factored into x times 5 times x minus 2. Then, even though they didn't write it down, I want to look at these before I cancel them out. Sometimes it's good to think of them ahead of time. X cannot equal negative 3. X cannot equal negative 1. And x cannot equal 2. So that's what they wrote down here. That's going to be my end restriction on the domain. Then they look for things that canceled out. There's a 5 there and a 5. Well, they used in colors, so that might be easier. 5 there with that 5 there, the x minus 2 with the x minus 2, an x plus 1 and an x plus 1, an x plus 3 and an x plus 3. Be careful of this x plus 1, because that was squared, so it canceled one of them, but there was still one left behind. Then you got to look at what you didn't cancel out. We didn't cancel out that x or that x, so it's x squared in the numerator. Then in the denominator we have an x plus 1. So there we go, there's our answer with the restriction x cannot equal negative 3, negative 1, or 2. Let's see what they have us try out for practice. We have 2 problems to try out. Click pause, come on back when you're ready. I think I'll show you the answer, and then I'll show you the problems you can do, and then I'll do these problems out if you needed more help. So if you don't want to see this, maybe mute it for the next, and close your eyes for the next 20 seconds. And here are the answers. Okay, and now I'm going to, homework that you can do from example 3 would be these 4, 23, 24, 9, and 15. I'm going to do those problems out right now. The x squared minus 16 factors into x minus 4, x plus 4. It's a difference of squares. Hopefully you practiced this enough, had enough problems of these that you can picture what these special cases are. This one, okay, it's an x squared, so all I need to do is find factors of negative 90 that add up to 1. Oh my gosh. Okay, they got to be numbers that are close to each other. Oh, 9 and 10. So x plus 10. Why did I know they had to be close to each other? Because when you add them together, you could only get positive 1. So I knew that one's going to be negative, one's going to be positive, and they have to be close to each other. All right, that is nicely factored into those 4 puppies. And now in my denominator, I'm going to have 9. Okay, here we go. 9 minus x. Now I know I have an x minus 9, so what I'm going to do, I'm going to write the 9 minus x as -1 times x minus 9. That way the x minus 9s will cancel. Okay, so look for that once in a while that happens. Okay, factors of 40 that add up to 14. I don't know. 4 and 10. Oh, that makes sense because they had x plus 10. That will happen a lot, that you'll have a common thing. So I'm going to use that. X plus 10 and x plus 4, which is also in the numerator. Cool. I like it when things work out like that. Okay, restrictions on the domain. -4, -10, +9. Those cannot be values for x. And this factors into, I don't know if I'm going to write it all out. The x plus 4 cancels with the x plus 4, the x minus 9 with the x minus 9, the x plus 10 with the x plus 10. So I'm left with x minus 4 over -1, which can be written the opposite way, 4 minus x. And remember those 4 numbers that could not be values of x. Actually 3 numbers. Moving on. Okay, x plus 3, that's already simple enough. This factors into, maybe I can write it right here, 3 times x minus 6. And the x squared is already factored. And now in the denominator, this can be risky because I might forget that I have some of this in blue and some of this in black. We'll give it a shot. This factors into 6 times x plus 3. Now, what does this factor into? I can take a 4 out, and I'll have x plus 3. Well, that's too bad. I didn't get x minus 6. Maybe I messed up somewhere. No, I don't see it anywhere. All right. Let me change colors. This x plus 3 cancels with this x plus 3. And I have a 4x, so let me get rid of this x with one of those. All right, what else do I have? I have a 4 down here and a 3. A 4, a 3, an x minus 6, and an x. Oh, I have a 4 down. Well, the 4 down is here, and the 4 down are here. I don't think that's going to factor. I'm going to write this one out. 3x times x minus 6. And then I'm going to go back and check the answer because, I don't know, this seems more complicated. 4 times 6 times 4, wow. 24, 48, 96. Oh, the 3 canceled, darn it. The 3 canceled with that to make it 32. I forgot about that. The 3 and the 6, I could have reduced it. And I still had an x plus 3. All right. Let's see if I messed up somewhere. X times x minus 3, 32. X plus 3, can't have those as zeros. Yeah. That's what I wrote. All right, I guess I did it right. And if you forgot what the homework was, it was these 4 problems right here. That's it for this video. Have a great day.